Hello everyone. We'll continue the next lab program. So till now we have completed first three programs. Now in this session we will talk about the fourth program. Again in this fourth program is exactly similar to the third problem. There also in third program also we are searching an element. Here also we are searching the element. There we have used the linear search, but here in the binary search. First let us try to understand what is binary. Binary search means, the first if you understand the concept that binary search, I think it is easy to write a code. So binary, here in the linear fashion it will just check one after the other, but here it won't do like that. It will take the entire array, it will divide two equal parts, and the target element, and first always that should be in the sorted order. I think that is what it is very clearly explained here. Always during the binary search you need to have the list of elements in a sorted manner. So whatever the elements you have, all the elements must be sorted in the first itself. That should be your input sorted. If it is not sorted, you need to sort, and then once you sort, that entire list will be divided into two equal parts, and then it will take the element or the target element, which element you want to search, whether that element is greater than that midpoint or less than. If it is greater than midpoint, go to this section. If it is less than the midpoint, go to this section. So again it will check if exactly the midpoint is matching with the target, no problem. If not, if it is less than, then again it will come this section. Again it will divide that the another section, whatever is less than midpoint, it will divide into two equal parts. Then the same procedure, it is a kind of recursion, whether it is equal to midpoint, if not, whether it is a greater or big. Greater means come here, lower means go there. Then again you have to search like that, it's keep on, it will divide equal two parts and search the elements whether it is greater or less, until to find the last element, or till to get the or if it is present. If not, yes, it has to process each and every recursion till to reach all the elements. If it is not present, then you have to return the return saying that the element which you are looking is not present. So the same concept. I think first we will try to understand what is the input. We will try to understand that. I think that I will explain it. Sorted list of elements and target function, or sorry, element. Process, the program initializes left and right pointers, as already I said, because it will divide and proceed at the beginning and end of the list respectively. What is the beginning and end of the list? And it will calculates the midpoint, middle index, mid, and compares the target. That mid index is compared with the element which you are looking, the target with the element at this index. If the target matches the middle element, exactly whatever the element you are searching, if it matches with that midpoint, then it returns that index. If not, if it is not matching with that midpoint or mid index, then it will check whether the target is greater than mid or less than. Greater than the middle element, it narrows the search to the right, whichever is the more. If it is big, then it will just your search will be only within that right margin, right of the list, by updating the left. If the target is smaller, then again your search is restricted to the only left of by updating the right. So this process continues, the target is found, and the same the process will be repeated till the target element is found. If found, otherwise it indicates the element is not in the list. So we can always as per our requirement. Here I think in this program I have given the static values. You can just change it, and you can make it dynamic, and at the time of execution, during the execution, you can send the input, both array as well as the the target or the element which you are looking. So we will just see the program now. See here, def binary search, again the same two parameters, the one is array we need and the element which you are looking. Now again left and right, as already I mentioned, we need the lower and the two ends. So that's the reason left is 0 and right is the element, how many elements you have. Suppose if I have 10 elements, so the length of array minus 1, because the index always starts from 0, right, that is the reason minus 1. If I have 10 elements, so it returns 10, but array starts from 0 to 9, even though it is 10 elements, that is the reason length of array 10 minus 1 is 9. Now I am just checking while left less than or equal to right, left value is less than or equal to right value, then you are dividing left plus right by 2, you will get the exact the mid value. So now the target you need to check, target is nothing but the element which you want to search. If array of mid is assume it is a 5, array of 5 is what? It is an index, whatever the element you get, you will get in the previous statement, that is an index. Array of 5 is equal to the target value is what? Probably I am just looking some 40. So array of 5, in that particular index what value is there, whether that value is matching with the target value. If it is true, then it will return the midpoint. If not, again it will just check whether your target is greater than or not. If greater, ignore the left off. So that's the reason array of mid, same array of 5 index greater than target. If S, go to the left side is equal to mid plus 1. If not, again if it is not greater, then you just go and modify right is equal to mid minus 1. So like that, it will check each and every element. So mid of whether it will divide and it will proceed, it keep on searching until it reaches to the end. If none of the element is matching with the target, then it return the minus 1. See, this is an array, this is a target element 62. So if I am just say same code again, if result is not, we are calling the function binary search of this array and this target, and it will return the result whether either left or right or minus 1. Now I am just checking result is not equal to minus 1, then element is found at the particular index. If it is equal to minus 1 or negative number, then element is not found the array. So here element 62 found at the index 5 as per the our data. This 62 is found at the index 5. This is about binary search, and the same explanation as already we discussed in the beginning of the program, the same explanation mentioned here in this particular slide. This is about the fourth program.